I gave my game a clock. Not because the exact in-game time was some critical missing thingy. I gave it a clock because games live or die on rhythm. Right now, this clock only changes light and mood, but later, it can drive the entire world. So let's get into it. Oh wow, nice and cozy over here. And look what we can see over there, it's the time. This day-night cycle in my game is extremely simple at its core. An in-game day starts at 6 AM and ends at 10 PM. And that whole day does not take 16 real hours, it takes currently 180 seconds. So in 3 minutes the world moves from morning light to daytime to evening and then night. And when the clock reaches 10 PM, it wraps back to 6 AM and increments the day count. But why is it the first feature? The obvious reason is mood. The game should feel different in the morning than it does in the evening. The sky should not always have the same color, the light should not come from the same direction forever, and the scene should not look like somebody turned on a lamp and then forgot that time exists. So the clock controls several things at once. Sky color, light direction, light intensity, ambient color, and ambient strength. That is what slowly moves the world from morning to the next day. But I will be honest, the more important reason is gameplay. Long term, I want to move closer to a Stardew Valley style feeling of day life. Not as a copy, but as a principle. Days should matter. Once the game knows what day and time it is, it can trigger events. NPCs can have routines, animals can wake up, walk or fly around during the day and sleep at night. Shops can open and close, music can change. Weather can affect the mood of the day and the behavior of the world. So the day-night cycle is not just there to make the sky prettier. It is the backbone for a future daily routine system. Today it controls lighting. Tomorrow it can control the whole schedule of the world. But before it turns into a 10 minutes of romantic skywatching video, let's just jump into the code and let me show you some good old pasta. The most important values are almost offensively small. So I defined some values you can see here. The names are pretty self-explaining, I think. The game does not simulate a full 24-hour day. It only simulates the playable part of the day, from 6 AM to 10 PM. And those 16 in-game hours are compressed into 180 real seconds. Instead of making time complicated, the system treats the day as one moving float value, the current hour. But hey, how did you implement the system? You showed us only the defined values. Yes, whoa, chill, okay? Now we come to the implementation, to the real implementation. Each frame game update updates the cycle, and inside that update, this is where the actual magic happens. This line takes data time and converts it into in-game time. If the last update took longer, the clock moves forward a little more. If the game runs at higher frame rate, each step is smaller. The result stays the same. 30 FPS or 144 FPS should not decide whenever evening arrives earlier or later. But when the current hour reaches 22 or higher, it wraps. This is not a huge calendar system, but it is enough to say, game, the day is over, go back to 6 AM and increase the day count. And that simplicity is exactly what makes the system useful right now. The next part is the visible part. It happens through interpolation. It estimates value between known data points. For example, the trick is not to hard switch the sky in the morning. The trick is to slowly mix colors. The game is not saying now it is morning. It is mixing night into dawn frame by frame. The same idea is used for light intensity and ambient strength. During the day it becomes much stronger. No, we got the sky, but we're missing the sun. The sun is basically math on a circle. Then it gets mapped on pi, so half of a circle. In the morning, the light comes from one side. At the noon, it is at its highest point. In the evening, it moves toward the other side. It is not physically perfect, but it is more or less readable, controllable, and good enough to create mood. Finally, we got to the last step. The last step is where the gameplay code talks to the renderer. The C code decides what time it is, and the shader decides how that time looks on the objects. In the fragment shader, the data becomes that, and after a bit math, we are done. That is how a simple clock becomes visible light. For development, I added some debug hotkeys. That is perfect for quickly switching between morning, noon, evening and night. And it is also a good reality check. If a system only works when you wait 3 minutes, testing becomes annoying very quickly. If you can jump directly to a specific time, you immediately see if the system is working or not. The current state is clean. Small state, predictable timing, smooth transitions, and already connected to rendering, UI, hotkeys, and saves. But the exciting part comes next. I want to expand the day-night cycle from a visual system into a gameplay system. First with day and time events, then with NPCs and animal schedules, and after that with weather that changes the world per day or over time. The clock already knows what day it is and what time it is. The next step is teaching the world to care about it. And that's where I'm leaving for today. If you made it all the way to the end, thank you. Seriously, those videos are basically me slowly building a little world in public, one system at a time, and it means a lot that you are here for it. If you enjoyed the video, leave a like, drop a comment and subscribe to the channel so you don't miss the next part. Next time we will take this clock and start making the world actually respond to it. So yeah, thank you for watching and I will see you in the next one.